Hello everyone, thank you so much for joining us. My name is Vijay Sairam and I will be your moderator for today's webcast on maximizing microservices, managing complexity and extending value with Apigee and Istio. A few housekeeping tips. You can find links to the references made during this webcast on the resource console of your screen. Should you have any questions, please feel free to post them anytime in the QA console. You don't have to wait till the end of the session, so please feel to post them in as soon as you have them. Also, we will be recording this webinar and it will be emailed to all the registrants of the webinar. In today's session, we will talk about the essentials for maximizing your microservices strategy. We have planned for a very practitioner-heavy session. We have 2 demos that will demonstrate how we are working to help you manage complexity and extend value of your microservices with Apigee and Istio. With that said, I would like to welcome our speakers for today's session. Nandan, Sridhar, Product Manager and at Google Cloud, and Scott Ganyo, Software Engineer at Google Cloud. Nandan has over 14 years of IT experience in financial services, enterprise architecture, software development, and IT consulting, and has played multiple roles of an architect, designer, mentor, and technical specialist. He currently helps customers design beautiful APIs through Apigee Edge, and he's deeply interested in the spaces of API security and microservices. Scott Ganyo is a prolific software developer with over 25 years of hands-on expertise in development, architecture, resource, and leadership, and is very passionate about microservices again. With that said, welcome to both speakers, and I would like to now hand it over to Nandan.
Thank you so much, Vijay. Appreciate the introduction. Thank you all for taking time to attend this webinar. So I'll give you a brief overview of what you should expect from today's session. We're going to talk about the concept of service meshes. What is a service mesh? Why do you think it's even there? What is Istio? The value proposition for Istio? How does Istio solve the problem? And then we'll have a demo of Istio. Right? After that, we're going to take a look at API management as it relates to microservices. How does service management and API management coexist, complement, or are they the same thing? And lastly, we're going to take a look at how Apigee integrates with Istio, and then we'll have a demo for that as well. So without further ado, let's go dig into this and see what is a service mesh. But a lot of enterprises either considering or have already started building new services using a microservices architecture. And we all know that microservices are awesome. So why is that the case? What was wrong with the previous mechanism? Well, this would be a fairly good generalization of a monolithic architecture. We've got some users. The front-end business logic is in a monolithic application that connects to one or more databases. Now, this architecture did have some advantages. If you did have a very complex application, this worked just fine. It was easy to, from a production point of view, easy to troubleshoot. If you had latency issues, you know exactly where to look. It's that one monolithic application. And if you had to deploy something, you just deployed that app and you're done. So there are some disadvantages to it as well. This severely impeded agility, especially as that application became more complex. Right? The front-end team may be making some changes. The back-end team may be making changes. Every change required you to test that entire monolithic application. And this was definitely a problem and increased the ownership costs for that application. And so we know that microservices solve that problem. So microservices started decomposing this monolithic application, started to decompose this monolithic application into independent units, functional units, so that development teams could operate on those functional services independent of each other. So in this example, that monolithic application was split into an invoicing microservice, a front-end microservice, a NoSQL DB cluster, and so on. And so if I were making changes to the invoicing application, I didn't have to involve the front-ending team. I could make those changes and iterate much faster without involving other teams. There are also some interesting byproducts from this architecture, not just related to agility. The first is that we could use the right programming language for our microservices. The front-end team could use JavaScript, Node.js. The invoicing team could use Spring Boot, .NET, or something else, and they really didn't need to have much in common. The second thing is that as one microservice called another microservice, i.e., when they transferred responsibility from one microservice to the other, they did it over the network. So a very common pattern would be that the invoicing microservice exposed its interface as an API over HTTP, and the front-end application didn't have to know how it was implemented or who it was implemented or anything. As long as that contract was maintained, the front-end application can invoke the invoicing application. So this definitely promoted agility. You could introduce changes much quicker, and this was definitely a huge benefit from the microservices architecture. As people started adopting more of these microservices, they started making them more fine-grained, and before you know, your architecture ends up looking like this. Because the more fine-grained you make it, the more quickly you can iterate on one of those individual microservices. Now, this, on the face of it, can look pretty daunting. Right? So what you're seeing here is a network of microservices that make up one or more monolithic applications. This network of microservices is what we call the service mesh. And as you can tell, as you build more and more microservices, this network can become massive and complex. And this complexity becomes very difficult to manage and understand. If you put yourself in the shoes of a production operator managing this sort of a microservices architecture, and you had a performance problem to identify, it's going to be pretty difficult to identify which microservice actually was causing the performance issue, because there's so many microservices running all at the same time. Another issue is with introducing agility while keeping your risk low. If the invoicing team is quickly iterating, making changes, what if it breaks? What if they pushed an inaccurate change that broke a contract and now it causes a cascading effect of breaking other microservices? And there's a third issue. What about governance? You have many teams developing microservices using programming and platform choices that they want to make that's best suited for their microservice. But then how does a security admin guarantee that they're all adopting best practices of security? How do you know that they're all adopting the right standards for logging, tracing, and everything else? So there is a governance issue now. So we identified three interesting things, right? How do you observe, right? The second is, how do you do operational agility without introducing more risk? And third, how do you do a uniform security from this? So it's easy for one to think that microservices are in fact terrible. Monolithic problems didn't have this problem. Well, obviously that's not the right answer. Microservices are perfectly fine. Yes, these three are an issue, and this is exactly why Istio exists. Istio is an open services platform to manage your service interactions on containers and VM-based workloads. That second part is super important. It's also for VM-based workloads. And I mentioned service interactions. That's exactly what a service mesh is, right? Managing the interactions of your network, of your microservices, is what Istio does. So what do I mean by manage them? And that's what we'll dig deeper into as we get into what Istio does. So Istio solves the three problems I brought up earlier when you're dealing with microservices. Gives you observability, right? Second, you can have operational agility, i.e. the ability to introduce changes quickly into your system without introducing additional risk. And third, you can introduce policies for security without having to depend on individual teams to adopt those policies. Right? You can, as an enterprise standard, apply broad security rules and not expect individual teams to apply them on every microservice. So this is a quick value proposition for what Istio does. Now what we're going to look at is to see how Istio does it. The basic architecture construct for Istio looks like this. At this point, I'll introduce the concept of a sidecar. Now you'll see here, I've got two services, A and B, and both have a proxy associated with it. That proxy is what we refer to as a sidecar. A quick definition here of what a sidecar is. A sidecar is a process that assists a parent process where the parent process can transfer responsibility to the sidecar. So in this case, service A is a microservice I've written, and instead of the microservice or the microservice developer implementing every bit of the microservice developer implementing every bit of the architecture, the microservice developer is offloading certain responsibilities to the proxy, the sidecar proxy. Now, you must assume that as if the sidecar proxy is part of your application. If the sidecar proxy is down, your microservice is down. It really is a one-to-one mapping, and most of the times they share a kernel. If you're putting it on VMs, and if you're not on VMs, they're in the same pod if it's Kubernetes. So for all practical purposes, that sidecar proxy is part of your application. That microservices team must treat that sidecar proxy as if it were part of that microservice. It is only then can you rely on the sidecar proxy to do certain or take up certain responsibilities instead of the individual microservice doing it. So what responsibilities can I delegate to the sidecar? Right. So first off, there are two things that a microservice does very often. Then it invokes other microservices, or it gets invoked by other microservices. So these are easily broken down into two aspects, ingress or an egress. Service A calls other services, or other services call service A. What happens with Istio is that the sidecar proxy intercepts all ingress or outbound, and all ingress or all inbound traffic to the microservice. So the microservice itself is never directly accessible without going through the sidecar proxy. And this is a fundamental point. When you have the sidecar proxy associated with every one of your microservices, you'll quickly realize that all your network traffic is happening between two sidecars. Never happens between the applications themselves. And this is a fundamental point to understand as to how Istio operates and how it is able to achieve the value propositions we talked about, i.e. observability, agility, and security. So now that we have established that all inbound and outbound services go through the sidecar, we'll now start talking about what is it we do and how we do it, right? So assisting the sidecar are three components. I'm going to briefly touch upon them now, but we are soon going to have a slide that explains individually what these components do. The first is Pilot. Pilot helps with service discovery. I have a slide about it, and we'll talk about it then. And the second is a policy decision point, which is Mixer. It enforces policies in the service mesh. And unfortunately, you can't see the slide here, but the last one is Citadel. Citadel will help with security. Citadel is a CA certificate authority, so you can achieve mutual TLS between your services. Let's start with security first. Right? So we've established a basic premise that there is a sidecar in front of all your microservices, and that sidecar has some delegated responsibilities. Let's start with security. How does security happen with Istio? There are three important security points that Istio provides. The first is enabling mutual TLS, that is authentication and encryption between your services. And this is a very fundamental point. Individual applications no longer have to implement TLS. My microservice in service A or my microservice service B need to have absolutely no knowledge of how to do TLS. Right? That responsibility of negotiating TLS is offloaded to Envoy or the sidecar proxy. By doing this, I have now implemented a standard way of achieving TLS. Regardless of whether it's a database, regardless whether it's a .NET application or a Java application, there is one way to do MTLS, and that's still using the sidecar. The second is to authorize access based on service identity. Another crucial and critical point, and I have a slide about it, but I'll briefly touch upon it here. The sidecar, or in Istio, every microservice has a service identity. And we'll come to that in a second. And then I can apply authorization rules on those services. So for example, I can say that only service A can access service B and no other service. That is achievable because we identify the workload.
for the service with an identity, a service identity, and that can be used to apply authorization. Lastly, you can also apply some very fine-grained RPC controls. For example, I want to allow service A to access service B, but it can only access the get operations and nothing else, or only the post operations and nothing else. And so it can also be a very fine-grained authorization. So let's take a quick look at what are these and what these options mean in detail. So of course, mutual TLS is a very standard practice for securing communication between two services. Mutual TLS, we all use it for encryption of messages in transit, but there is some more we can do with this. What Istio provides is this ability called a strong authentication, and I touched upon it briefly before. Istio provides the ability to create a service identity. Now, how do we do this? So there is a standard called SPIFFE, S-P-I-F-F-E, for those of you who are interested, and Citadel is a certificate authority that is responsible for signing certificates in this standard. So when service A is brought up, service A gets a unique service identity. No other service can pretend to be service A. I can uniquely identify service A, and this is extremely useful to authenticate that my service is in fact coming from service A and not someone else. So it's easy for me to have a rule in service B to say, I will only accept communication from service A. In order for me to do that, I must have a strong way of achieving the identity that is service A, and this is done through SPIFFE-based certificates. A second very critical point is how these certificates are automatically rotated. So every 30 minutes in Istio, a new key and cert pair is generated, and this new and key cert is issued to service A, and these certificates keep rotating. In my past life, I remember we struggled a lot when it came to certificate upgrade with these giant monolithic applications with the Java key stores and everything. There was at times downtime for us to upgrade these certificates. That could be a thing of the past when you use Istio, because certificates are rotated all the time, every 30 minutes, and automatically. The second component I want to introduce here is Mixer. Mixer is that extensibility point that allows you to make policy decisions in Istio. Mixer integrates with Apigee, Mixer integrates with Stackdriver, Mixer integrates with Prometheus and Grafana, and all these other systems. So Mixer has two main roles. The first is that it collects telemetry information from the Istio architecture. We talked about how there's a sidecar in front of every application. This presents us with some very interesting options in addition to MTLS. These sidecars can emit events every time there's an ingress or an egress. Those events can be captured by centralized systems to produce tracing information, monitoring information, so you get observability without changing any of your applications regardless of the code they're written in. Mixer is that centralized place where these telemetry events are collected. But Mixer also has another role to play. Mixer is a policy decision point. This is where you can code your authorization rules to say, I want only service A to access B, or I want service A to only have read access to B, and so on. These are authorization rules or policy decision rules that I can encode into Mixer, and those decisions are then enforced by the sidecar. So Mixer provides that extensibility to add those custom rules into Istio. The last and final component here is Pilot. Pilot is responsible for configuring a control plane. So Pilot has two jobs. One is providing service discovery information. When you have a new service that is registered, Pilot knows about it and lets the sidecars know about it. And second, if you're doing things like canary releases, A/B testing, all of these rules are coded into Pilot, and Pilot pushes that information to service A. So in this case, if I had a new version of service B, and I want to send 20% of my traffic to this new service, then here is an example of a YAML file of how I could do it. 80% of my traffic still goes to the existing service, 20% goes to my new service. And this is a very critical point in maintaining operational agility. Right. We talked about two things. We talked about observability, we talked about security, and this is the third one. This is how we introduce operational agility. This allows development teams to iterate very fast because when you do introduce a new version, you don't have to send 100% of your traffic to this new version. You could start with 5%, test if there are errors, and if there are errors, easily switch back to the previous version. If there are no errors, continue to increase traffic to this newer version. What does Istio do in summary? The value proposition for Istio is that managing microservices can be complicated. It presents a challenge to production operators of how to get observability, how to introduce operational agility without increasing risk, and third, how to do policy-driven security so you're not depending on individual teams to do it. And Istio addresses these concerns on behalf of the application or the microservices provider by baking these features into the basic infrastructure. Istio can do the routing, Istio can do the security, and Istio can introduce the observability for what is happening in your infrastructure. So at this point, what we are going to do is I'm going to get my colleague Scott Ganyo is going to do a quick demo of Istio, and is going to show you how Istio works.
Thank you, Nandan. What I've put together here is it's a storefront. So that I'm going to operate now at this point as the operator of my store here, and I'm pretty satisfied with what I've got. I can go in and buy typewriter, add it to my card, view the card. I've got all of the standard capabilities that you would expect in the storefront. Now, this whole thing has been created as a series of microservices. Now, all of this is actually deployed in a Kubernetes environment, and each of these services is developed in different style, different language. We have everything from Python to Java to Go represented here, as well as database information and accessing external services as well. So the issue here then, of course, as Nandan talked about, is how do we manage all of this? Well, the first thing I want to show you is a very simple thing, but a very powerful thing, and that is being able to route information as like a canary type implementation. And so Nandan showed you a version of the YAML. This is a slightly different version. And you notice my shop is a lot of gray. That's my color. But I've heard now that blue is the hip color. And so what I've done is I've rolled out, or I've deployed a version of my app that takes into account the fact that I've heard that people like blue. So what you see here is I've changed the virtual service, and I've set up a destination. So a subset of 80% of the requests go to gray, and 20% go to blue. So once I apply that, so we're configured now. Now, whenever we go through here, you'll see every once in a while we'll get a blue page. Oops, not on that page. But my header is going to be either gray or blue, depending on how we hit it. So that's cool. That means I can test that small change in an A/B way or in a canary type rollout. And I can easily get back from it, because it turns out that my customers actually really preferred the gray. And I can just roll that back with another quick change where I set 100% of my traffic back to gray, and I will never see that blue abomination again. So that's a quick example of how you actually use the routing capabilities. Another thing that I want to show you real quick, though, is some of the monitoring. Now, if we jump in, we have full telemetry information and tracing information, and this is the Jaeger UI, and it shows you the requests that have been coming through. And I can actually drill down into one of these and see exactly where all the time is being spent, like what's being called and how long it's taking. So if I need to get information and about the actual operation of what's going on, I can very easily figure out where I need to make optimizations or I need to make changes to fix things. The other thing I wanted to show you is Grafana. And if you look, we can get a very detailed view of the information about the system, of the memory, CPU, all the information about that. I can also show you the service dashboard, front-end service, and it shows you request volume, success rate, things like that. So we have very detailed information about what's going on in the system, and all this is just absolutely built into Istio and available at all times, and can be extended as well, various plugins. So I'm going to hand this back to Nandan now.
So what we have seen now is how to use Istio to do basic service management. Right? What you've seen with service management needs are basic ability to do MTLS, so you can encrypt and authenticate your traffic. Second, you want to have this operational agility, so you can do A/B testing, you can do canary releases, all of that. And third, you want to do policy enforcement. They apply to all services, right? And this is back to that. So how does service management really tie in with API management? So first, let us establish what is API management, and then let's talk about how service management compares with API management. API management is the ability to provide an API catalog for discovery. If you go back to this architecture here, this is the application that Scott wrote. It's got a currency service, it's got a checkout service. Very frequently in enterprises, the team that builds the currency service is different from the team that builds the checkout service. Now, that team that builds the currency service will very frequently want to have exposed that service in some sort of a catalog that's available in the enterprise. And the team that builds the checkout service will refer to the currency services API specification, potentially request access to it, and if access should be granted by the team that builds the currency service, they will grant that access and then you go ahead and build it. So while at the service-to-service communication path, none of this was visible, at the development stages, when these services were in fact being shared between teams, API management was definitely needed. So let's reiterate that. If I am just building some services that is only ever going to be consumed from within my team, then by all means, something like a Java doc or a README file is good enough to share information about how to consume that other service. But the minute you want your service to be available outside your team into a consumable form, then you want to have a catalog to publish it. The moment you have a catalog where people can consume your services, you want to have the ability to control who has access and how they have access to it, and so on. The next step is from the ability to view usage reporting. You saw Scott show us the distributed trace, which said, this is how much latency it's spent in every single microservice and so on. But neither Grafana nor the Jaeger UI showed Scott who his top biggest 5 applications are, because Istio does not have the view of an application. It has view of services, and many services form an application. Like, for example, your call center application isn't one big application, but it is a bunch of microservices. But if you want that view of what does it look like from an application level, which is a logical grouping of microservices, you want to have some analytics being reported. If you want to productize your data and expose it to others for monetization purposes, very likely you're not going to productize individual microservices, but you're going to productize a logical grouping of these microservices and make it available as a single API. And lastly, of course, you want to have the ability to do documentation, try your APIs, and so on. Then there is the aspect in an API gateway. Within an API gateway, I want the ability to do transformations and mediations. I want the ability to do throttling and quotas. I want threat protection for my JSON and XML payloads, and I want some caching optimization techniques to be available. These are certain cross-cutting concerns that you want in a gateway so that, again, individual microservice developers don't have to do it. So keeping these in mind, let's now compare API management and service management. All APIs are services, but not all services are APIs. Your caching service is a service, but it's not an API. Your website is a service, but it's not an API. But the invoicing service is also an API because I could invoke it as an API. So we think that Istio and service management is needed for all services. Anything with at least a TCP port can be managed by Istio. So that could mean your database, that could mean your NoSQL database, whatever that may be. And when some of those services need to be exposed for consumption outside of your team, then it becomes an API, and you need API management for it. And that's how we try to look at API management and service management. They are really complementary functions. Even if you drill down into the features offered by both of them, you'll notice that although the feature set can look similar, they offer different perspectives. API management, of course, works on HTTP-based APIs, but service management can apply to a TCP-based service, and that's perfectly fine. When it comes to authorization and authentication, service management relies on mutual TLS and the identity in the SPIFFE certificate for identity, whereas API management can rely on API keys and OAuth tokens and not necessarily at the MTLS level. When you look at monitoring, it's really monitoring from a production operations team point of view. It's a production ops person who wants to know the distributed trace to find bottlenecks. Apigee's monitoring is more from a API's provider point of view, where you're going to try and take it as which application that's consuming me is causing the most errors, who are my top 10 developers, and you see how this monitoring almost bleeds into analytics. Rate limiting is also very different. A rate limiting for service management is more to do with, I want to protect my backend. But a rate limiting from an API management point of view is from a consumer point of view to say, I don't want these consumers to exceed their quota. I want to create a gold tier. I want to create a platinum tier. I want to create a bronze tier and so on. These are all consumer specific. They're not backend specific. Lastly, monetization and portals are abilities that come with API management. You don't really monetize services, you monetize APIs. So I hope you're drawing this distinction of how service management and API management are complementary features. Service management is needed for all your services, and when some of those services become APIs, you use API management. So how do we Apigee integrate with Istio? Now, assuming that you've already got Istio to do services management, then how do we layer on top of this to also do API management? What you're seeing here is the architecture that we have for services management. It includes the sidecar, it includes Mixer and Pilot, and I have on purpose not introduced Citadel here. It's not relevant to this current conversation, but it could have been here. So I've got service management here. In my previous slide, we talked about how Mixer is that extensibility point. And as you would have guessed it, naturally we would extend Mixer to add API management capabilities. In addition to that, we introduced two important concepts: the concept of an API portal and the concept of an API dashboard to view the metrics. And Mixer becomes the policy decision point to do API key or OAuth verification. It's the point where you do quota enforcement, and it's also the place where you collect analytics to send it off to the dashboard. The next point is, how does Apigee do it? Well, naturally, we integrate the Mixer component of Istio to talk to Apigee Edge or the control plane in Apigee Edge so that the Istio Mixer is Apigee aware. And this is a very critical point. You have now, with the integration of Mixer to Apigee Edge, you have now made Istio Apigee API management aware. Mixer is now able to enforce the rules that you define in Apigee. So Apigee becomes a place where you author entitlements. Apigee becomes a place where you publish your services for your portal. And those rules are pulled down by Mixer and then enforced in the service mesh. So let's take this with an actual example. We had the retail site Fazio that Scott built, and now Scott has got a new requirement. This new requirement is the shipping service needs to be exposed externally, right? And that's the requirement he had. So far, the shipping service was only used by the checkout service, and that was never exposed outside, and it was all done through the front-end application. But now his requirement is to actually expose the shipping service as an API. So Scott, tell us how you would do this.
Okay, thanks, Nandan. So what we're going to do first off is expose our new tracking API. We have a service, and we already have a gateway that's exposing the application itself. But what we need down here is to expose the tracking and route it to our shipping microservice and allow access through that. So once we apply this, then we will have access, it's configured, we will have access into this API, as you can see here. The next step that we're going to look at is wiring up Apigee. So we need to be able to apply Apigee analytics to our Istio routing or to our Istio application, and we also want to apply authorization. Right now, I'm going to show you a little bit of how that wiring happens. The Apigee analytics, as you can see here, this little CRD basically tells Istio Mixer which attributes in Istio to send to Apigee. And you can see we have request times and destination hosts and things like that. So this is the analytics part. And then we also have a template for authorization that tells Mixer which parts of the authorization, when it does authorization, which attributes from Mixer need to go to Apigee so that we can do that as well. And here you'll see API, things like API key, and you'll see claims from OAuth and things like that. So in both cases, we're able to report on not just the request itself, but who's making the request. The next thing that we'll do is apply a rule. Now, this is what actually tells Mixer that we want to send, in this case, we're going to send all inbound requests to the Apigee adapter and thus to Apigee. And this is for analytics, so we'll take everything that there is. Configure that rule. And now we can look at the analytics reporting. Now, when you get into Apigee Analytics, it gives you all kinds of great information. This, for example, shows by device type. But you can drill in on this one to various services. So we can look at, the product catalog service and how it's, how it's being hit. We can look at error code analysis and actually see if we're getting errors, and we're not getting many. We can look at developer engagement is interesting once we have a set of developers, and we'll talk about that in just a moment. And then actually API proxy performance as well. So you can see all the developers, and you can be able to sort them by email, so you can see that. Okay, so we have all that coming into Apigee now, but now we need to expose what we're doing to the developers. And we do that through a product. And when we create an API product, this is what actually gives us the control over how the API is accessed by developers. So what you see here is I've created a product called Tracking Details, and I've made it publicly available to any registered developer. So once they've registered, they can have access to this. And it's automatic approval. Now I've set a quota, so any developer can actually only access this 5 times each minute. I'm not setting any OAuth scopes right now. I set a path of /, which basically means they have access to anything, any paths on this particular product. And then the interesting part here is the Istio services. Now I've bound this to the particular service that I've already deployed and that I opened up access to a second ago. And this is the shipping service. And this is the full DNS name of the shipping service in Kubernetes. So having set all that, we save that. And we come back, and now we can register to use that API in the portal. So I come to the portal and check out the APIs. Oh, there's my API. It's a tracking details, and I've already exposed this to the portal with an open API definition, as you can see here. If you look at this open API definition, we have a get tracking, and you pass it a tracking number. And the body of a response is going to have information such as the carrier, the status, tracking location, things like that. And then you can see here, we also have the authentication requirements that it requires either an API key or a JOT-bearer token. So right now we don't have it protected, so we should be able to access it with no additional work. And there we go. So we get a correct response. Now that's great. I can try the API. But what I really want to do is create an app so that I can use the API as a developer. Because normally you're not going to have the API open to just anybody, right? So what we're going to do is protect the API with an API key. So now I've said that my API is no longer public. It has to be a registered developer because you have to have an API key to access this. And you'll notice that we're saying we're only doing it for the shipping destination. And that's so that our app can continue working as normal, the web app. And this only affects that shipping API, or the shipping service, in fact. So let's go back to the portal again. Now, let's go here. And now we should see, if we execute, yes, we have a 403 permission denied. Now we have to have an API key to access it. And we can do that ourselves as well. But what we have to do is we create an account and sign in. Now I've already created an account. So I'm going to log in with my account. And if we go here, you can see that I don't have any apps. Well, I have to create an app. So I'm going to call it my details. Now, once the app is created, you'll see that I have access, or I grant access to this API and add an API key for the app. Now, this should be able to be used directly to try out that API. So let's go back to this API. So now we're going to authorize this with the API key that we just created. And actually, let me manually enter it. I'll show you the key, authorize. And we get a 200 OK, and we're back in business. Excellent. So API key is working for us. So now we need to try this with OAuth. First of all, we'll go ahead and protect it with the OAuth. And you can see here we have an auth spec that tells it we're using my issuer and where I get the tokens and where to retrieve my certs from. In this case, we'll go ahead and apply that. Now, when we apply that, that actually goes out to the proxy. So it's actually running on the Envoy, and Envoy retrieves that information and can evaluate that right there. So let's go back to the portal once again. Now we'll try it with the same authorization that we had before. And this time we get origin authentication failed. It's a different error because that's coming from the proxy. So now what we need to do is we need to go back and we have to get a token. So to get the token, again, go back into our app. And we're going to need the key and the secret. So let me grab the key, and I'm just going to go ahead and put these in here. The secret, put that in here, evaluate that, and then see if we can create this token for us. Here's the token that it's created. And this is the actual contents of what that token looks like. And you can see that we have all the information about the user in this. So let's grab this token and go ahead and put it in the bearer header in this access. And you can see now we have access again. And I'll turn this back over to Nandan. Thank you.
What you've seen now is the ability for us to extend the Istio mixer adapter to apply API management rules in a service mesh. So service management provides the value of applying observability, operational agility, and security to your microservices. Apigee extends service management in Istio to give you the ability to have a portal to get API analytics, and then to apply API management rules within your service mesh, like quotas, API key verification, OAuth, and all those things that you typically associate with a service, with API management. So I hope you guys like this talk. I'm going to pause here and see if there are any questions.
Once again, thank you for attending the webinar. Before we get onto the Q&A, a couple of quick things, Apigee customers can sign up for for starting to use the entire integration with Service Mesh, and then you have the other links over there with regards to what is available. You have resources which will be made available to you. They're available on the resource console. So those are you can go ahead and download those thought leadership documentation. With that, I would like to quickly get on to the questions that we have. We have a lot of questions. I'm going to tap it out to 2 questions that I believe Nandan, would you want to take them up? One is Mixer Adapter the only way of integrating more with Apigee and Istio currently?
Yes, within Istio itself, that is the point of extensibility. That Mixer is where we extend it. But of course, our portal analytics, they all read off of Mixer, so you get those benefits just through the Mixer extension.
Fantastic. And I just have one final question because I got a lot of things about this particular question is with regard to the 30-minute key rotation that was offered by Istio. Is that something that's configurable? Can you give us some more information on that?
Yeah, it is configurable. 30 minutes, I believe, is the default, but you can increase it.
Okay, fantastic. Unfortunately, we are completely out of time. We will not be able to take any more questions. But before we go, thank you for your attendance. We really appreciate it. Thank you to all the speakers. I wanted to call out special attention to the next webinar that's coming up on September 26th. It's about the craft of API product management. It's going to be a great session that will talk to you about frameworks, business models, and KPIs that you as an API product manager need to take note of. We're also going to have some experiential learning where we have customers, enterprises just like you, who are going to share their story as to how they've done. Some of these experts are going to provide as to what kind of lessons they've learned and what are the kind of advice they can provide. So please feel free to register for the webinar, and we look forward to learning along with you. With that said, I think we're completely out of time. Thank you. We really appreciate your time today. Have a wonderful rest of your day. Thank you.